Okay, this is question number 2. So we have a wire coil, and around the wire coil we have some levels of insulation, or we have a pipe, and that the pipe's measurements is 0 to there is the radius of the pipe is 10, which means this function only exists from 10 to 50, because if there's no insulation, then x is 10. Then if there's insulation around it, we end up with a wider value, which is why this graph starts at 10 and finishes at 50. And this is heat loss. It's not heat. So if we've got a value of 30, it means it's losing 30 amounts of heat per time. So it's a rate graph, sort of like it's the derivative graph. Okay, so part 1, find the rate at which heat is lost when the water in the pipe with no insulation, therefore at 10. So I've got my expression up here. And if I put that into a new line and I make keyboard math 3 given x equals 10, and then I end up with that value, and I'm doing it to 3 decimal places, 28.562. And if I was to graph, I would change my windows to match the graph, so 0 to 50, and y goes from 0 to 40. And if I want to have the graph with a restricted domain, I'm going to include the restricted domain, and when I drag and drop, it will only draw it for that restricted domain. And if I do analysis, gsolve, ycalc, when x equals 10, it's going to give me 28.562, same answer. Okay, state the derivative of h. That's a bit of a silly question. Okay, so if I just get the derivative and I go keyboard math 2 derivative with respect to x, it's an awful answer. Simplify that answer. Did it come out any nicer? It did. So I'm going to write h dash of x equals -3200 bracket 2 log by c of x minus 5 plus log by c of 1 on 16 minus 1 all over x minus 5 squared cubed. And don't change anything. Find the maximum rate at which heat loss is lost from the water, correct to 3 decimal places. The maximum rate. So the maximum rate is going to be this value here. So I could, at 3 decimal places, so I could find analysis gsolve maximum. And there it is, and it'll be 36.7894, 36.7879. So I've got 36.787944 to 3 decimal places, 36.788 will be my answer. A particular insulated pipe is the same rate of loss as water. No insulation, find the thickness of the pipe. Okay, so if I was to put on, I knew that for none, the answer was this value. So if I draw that and I do analysis gsolve intersection, there should be this intersection at 15.28. So 15.28750, 15.288 should be the answer, but it's also losing the same as what it lost at 10. If both the radius of the pipe without insulation and the radius is doubled. So if it is doubled, then I am doubling everything. So this becomes double and this becomes double. Therefore, I'm stretching it this way by a factor of 2. So I have a dilation by a factor of 2 from the h-axis. Therefore, I replace x with x divided by 2. So what do I need to do? I need to show that that's the rule. So h of x equals 3200 over x minus 5 squared log by c of x minus 5 on 4. Then I have h of x on 2, and that's going to equal 3200 x on 2 minus 5 squared log by c of x on 2 minus 5 on 4, and that's going to give you that answer up there. 12800 on x minus 10 squared log by c of x minus 10 on 8. And describe the transformation dilation by factor of 2 from the h-axis or the vertical axis. And over the page, find the area between the graph of h1, the horizontal axis over its domain. So it's h1, so it's this new rule. So we're integrating from 20 to 100. I think there was an extra answer. State the domain. The domain of h1 will now go from 20 to 100, not from 10 to 50. Of h1 x dx, throw that in the calculator. So what have I got in my calculator? I'm going to have this, and I'm going to bring up my keyboard and copy it. I'm going to come down and paste, and I'm going to replace the x with x divided by 2 and the x with x divided by 2. And that's going to give me that, and I've simplified that answer. We get the same as what we had. So we're now going to integrate that from 20 to 100 dx. And that gives me an answer of 1079.171. So 3 decimal places, 1079.117, and so that's A, and that's the stretched one. So determine the area between H, what's going to be A on 2? It's going to be half of it, because we stretched by a factor of, dilated by a factor of 2 to get this, therefore my original would have been A on 2.